Hi everyone, I'm Ruofan Liao from Tokyo Institute of Technology, and today I'm super excited to present PianoSyncAR, enhancing piano learning through visualizing synchronized hand-pose discrepancies in augmented reality. This work was done with my awesome collaborators, Erwin Chen-Chieh Liao, and Hayato Nishioka, as well as my amazing supervisors, Shinichi Furuya and Hideki Koike. Learning to play the piano is a very complex activity with various aspects, such as sight reading, tempo control, emotional expression, and motor skills. Among these factors, physical domains are particularly vital but challenging. Even for me, I've learned the piano from 6 years old, but sometimes I find it hard to correct my hand pose during practice. In advanced piano performing, this issue matters more, especially for experienced pianists who seek to further sophisticate their skills, since discrepancies become subtle as the proficiency levels improve. So there's been a lot of work done in exploring the assisted techniques for piano learning. Early in 2020, researchers suggested using soft exoskeleton gloves to support hand pose training. However, they required complex setups and inconvenient equipment. Last year, an AR rhythm game called Piano Vision emerged to accelerate piano learning using mixed reality. But it's more like using gamification to make practice more enjoyable. And most recently, a multimodal performance dataset as well as an MR application was developed to assist novices and intermediate piano players in learning how to move their hands. But overall, these systems are either inconvenient or too bulky, and there are no tips for posture discrepancy. Users' performances are not synchronized with references. Hence, it's difficult to compare two performance motions and learn the correct postures through imitation. On the other hand, a training system focused on piano pose visualization, actually is our previous work, which simply displayed the pose discrepancy on a touch screen. But from the pilot study's results, it was found a flat screen is confusing and not intuitive or operational enough for pianists. So instead, in this work, we explored the efficacy of visualizing performing hand pose discrepancies in AR for piano learning. As for the approach, our PianoSyncAR can enhance piano learning through visualizing synchronized hand pose discrepancies in augmented reality. And here's a detailed look at our system architecture. So at first, the hand and keystroke tracking system captures the user's hand posture data and keystroke data in a piano performance. Next, because the users and references data might be different in timing and speed, synchronization is crucial to obtain meaningful discrepancies. And then this data is fed into our custom neural network, keystroke TCC, which can produce aligned performing motion data. Hand pose discrepancies are then finally visualized in the AR world to help piano learning. In our AR interface, the discrepancies are categorized into two tabs, the intraframe and the interframe. The intraframe are colored regions on the virtual hands, with different colors representing different error degrees, while the interframe are some colorful error bars on the timeline, which highlight the mistake-made time points. Besides, user can use gaze input to change playback speed and visible hands. Now let's see how useful our system is. We conducted a user study with 12 professional pianists. And there are 3 conditions to be evaluated: video, touchscreen, and the AR system. As for evaluation metrics, first of all, we recorded performance before and after training, and hence could analyze the performance using some quantitative indicators: spatial deviations, temporal deviations, and keystroke intensity. Moreover, we collected user feedback from questionnaires and comprehensive interviews. So here are the results. The performance analysis results showed our AR system can somehow improve the training effectiveness when compared to screen and video. Here, PAS is the decrease of MPGPE from pre-training to post-training, while AAS denotes the MPGAE's change. Both lower PAS and AAS can indicate better improvement training. And we can see a trend here that our AR tends to show lower values. From user feedback, we can reach a conclusion that AR is better than screen in helpfulness, intuitiveness, and operability. Also, in the interviews, all participants agreed that the AR system can serve as a useful assist tool for traditional piano teaching, especially in efficient posture correction. For example, one of the pianists commented that only when using AR that he realized his postures were wrong. And other pianists concluded that the video to see the whole and AR to see the details. Except for all the aforementioned results, we also found very interesting things, like postures in AR are easier to perceive and imitate. This is because, obviously, compared to video and screen, AR is more intuitive and immersive. The user can see a real 3D content other than pseudo 3D on a flat screen. Also, AR combines teaching area and practice area so that user can just overlay their hands to the reference for more direct imitation. As we mentioned before, AR is simplified but more efficient in posture correction, which means AR should be a supplement instead of a replacement for video learning. There's a trade-off. Since video can convey additional information like muscle, skin, shape, while AR can just display posture skeleton. In conclusion, the user can achieve effectiveness in learning posture using AR and grasp other necessary information using videos. All in all, our PianoSyncAR visualized synchronized hand pose discrepancies in AR to assist piano learning. And furthermore, we envision extending this process of synchronizing, visualizing, and displaying in the ISMAR world to other domains of skill acquisition. Thanks, and see you in the conference.